Greetings, fellow men. Servus Männer. It's Red Pill Germany again, and today I want to make a couple of remarks about sexual reproduction and evolution in general. So for starters, you often hear the phrase of copying one's genes or making a Xerox of yourself when people refer to having children. Now I know this is just a sloppy way of speaking, but my pedantic scientific side cannot let this slide. So I have to say really that the offspring of sexually reproducing organisms are not copies of their parents. Clones are copies of their parents, or the resulting two cells in cellular fission, that is asexual reproductions. They would have identical genetic makeup, and their genes would be exactly the same as the cell before fission. We are different, of course, and every child or every offspring of a sexually reproducing organism is genetically unique. The only exception is identical twins, of course, but if you exclude the case of identical twins, every person is genetically unique. There is no two people that are genetically the same, except for, again, identical twins. And also you often hear these undertones that humanity is just reproducing and having children doesn't make any sense because we don't change and we are just basically copying this vegetative state on this horrible rock, this rock of dirt that is planet Earth, and humanity doesn't go anywhere. Now, maybe there is no heavenly purpose to our existence, but it is wrong that there is no direction. There is a direction, and people do change. For example, Dutch people used to be small people among European people. But in the last 150 years, they actually gained more than 20 centimeters in average height. Yes, average height. So we know that from military records and the uniform sizes that military men were wearing, and they are measured, and of course when they go to the military, so we know these things very well. 20 centimeters of average height, that is quite something. So that means a man who is maybe 100 years old, he might have seen the old guys when he was a child and compared them to the 18-year-old guys of now, and it will look like a different race to him actually, and this is unprecedented in human history, I think, that there was ever a population of people that was as tall as the Dutch people, to my knowledge. There have always been exceptionally tall individuals like Goliath from the Bible maybe, or something like that, but there was never a population that was that tall on average, and that only happened in the last 150 years. So you see that evolution through environment and mate selection can actually be surprisingly fast. Our genes, our body, our physiology can change dramatically fast because of sexual reproduction. And why is that? So in asexual reproduction, for example, the only way you can adapt is mutations. So random, accidental occurring changes in the genome. And this is actually the only source of variation that there is in asexual reproduction. However, in sexual reproduction, the genes are combined of male and female, and what comes out is entirely new. And in this way, the population, the organism, can adapt to the environment much more efficiently. And sexual reproduction is not always the best way to go. For example, in a very stable environment, when the organism is already well adapted, asexual reproduction is actually the best way to go. However, if the environment, so the fitness pressure, so to speak, the selection pressure varies in time or in space, sexual reproduction is actually best. And also, if the organism is not yet fully adapted or well adapted, sexual reproduction is definitely the way to go. It also helps us to keep up with parasites and diseases, for example, as they also have some evolution going on, and we can adapt to these threats by having an accelerated evolution ourselves. It also helps to take care of genetically occurring diseases, sexually reproducing organisms are very superior in this respect. So now that I think about it, I think the occurrence of sexual reproduction was probably the biggest revolution when it comes to life in the universe, or at least on this planet as we know it so far. This really changed the deal of evolution of life on the planet. So when you think about it, we had common ancestors with fish, for example, yeah? And just by mate selection basically and environment, one branch at this bifurcation point, at this crossing point, developed into fish or flowers or I don't know, other mammals, what do I know? And the other branch became eventually us. And that is quite fascinating, I think. Also, it is quite fascinating to think that our ancestors just left Africa 2 million years ago. And they didn't even cook their food yet, and they didn't even use tools at that point. So that means just 2 million years ago, they were humans, of course, already. Just 2 million years ago, they were humans, of course, already, but they were very different from us. And who knows where this journey that we're on will actually go, where our descendants will be and how they will look like, how they will act, how their societies will look like in 2 million years. I know that we're normally not used to be thinking in these large timescales, but I started actually to think in these large timescales now. And this is one of the reasons that I want to have kids actually, because I'm an experimental physicist, not a theoretical physicist. You know, I don't want to be an observing bystander. I mean, I know it's just a tiny incremental step, but I like the idea that I'm somehow part of this evolutionary process really, and that my genes will be mixed with the genes of someone who lives on a far removed remote island, and my ancestors actually never had access to these genes, and we will mix again. That is a fascinating idea, I think, and we will see what comes out. So I don't know about you guys, but I definitely adopted this way of thinking, that everything we do is just a tiny incremental step in a big mesh or a big network, a big web of linked chains, if you wish. And it doesn't matter if it's socially, technologically, or biologically, actually, you know. Every generation that is just a little dot in the big picture is doing their tiny incremental step, their tiny contribution. And even geniuses like Isaac Newton and Albert Einstein, for example, did not take us from harnessing fire to building the jet engine. I mean, just think about Neanderthals sitting in some cave and they're getting frustrated and they think, oh man, why don't we have lasers and jet planes? That is so frustrating. I mean, why are we even getting up in the morning, right? It takes a lot of incremental steps, and even the biggest geniuses just do that, an incremental tiny step. And there is no single person who can bring us from the cave to the surface of the moon. And in the same way, no single generation can bring us from the moon to another solar system. You know, unless some great revolution happens now that I don't foresee, I'm pretty sure that it will take a long time, and maybe it will take 10,000 years until we can get to another solar system. Who knows, right? But I'm not disappointed or frustrated or something. I just think I do my little tiny incremental part, and I hope for the best for the next generations. And maybe in a million years, there won't be any humans anymore as we know them now. Maybe we will not have bat wings and octopus heads like Cthulhu, but maybe we are a little different from now. So to me, these ideas are really fascinating, and it is really all environment and mate selection in the end. And as you can see on the map of the history of vertebrates, for example, there are a lot of families that are branching off into other groups and that stuff. So I wonder, I mean, this process, it doesn't stop. It's not stagnant. It is still ongoing. The way our biochemistry is made up, it is impossible for a species to stay the same, actually. It is literally impossible for a constant state here. This never happens. So the way we are evolving at the moment, this is still ongoing. It's like an explosion. You cannot freeze it in time. It is set in motion, and it is going on. It's like a big chemical reaction on the surface of the planet, if you wish. So I know this is science fiction, but just imagine how this map here will continue to the top, you know. What other life forms would evolve in 2 or 10 million years maybe on the planet? And will we have been their ancestors, or are we a dead end in the game of evolution? That is another important question. Or will there be another crossing point? And there will be several organisms in the future. Some might be brutish and animal-like, and some others might appear to us as gods if we ever met them. But they will all have us as common ancestors maybe. Just like we have common ancestors with single cellular organisms, you know? And this is really where I wish I was an immortal or a spirit roaming the earth who could still be around in 100 million years and see how the story goes on. But that is maybe the only thing that is really frustrating, that I will not see probably how this will evolve. You know, I just have a very, very finite lifetime. However, I noticed that there are humans on this world who think in terms of more than just 10 years, but they even think in terms of more generations. And I think there are some people on the planet who start thinking in terms of thousands or even millions of years. And that is maybe a new thing. And I just want to add one more thing at the end. There is a movement called anti-natalism, where you think that the earth is horribly overpopulated and it would be totally wrong morally to bring a new baby, a new person basically, into this horrible world with hunger and poverty and war. But I don't know. I don't really think like that for 2 points. One is that this overpopulation thing is really from the 70s, from the Club of Rome. And since then, a lot of things happened. Agriculture became much more efficient because we have better fertilizer and we have biotechnology now, and the output of 1 square meter of soil has actually been increased a lot. So we have enough food, so there is no real food shortage anymore on the planet. There is a problem with war and conflict, of course, and that causes poverty. I think corruption and just bad governance probably is the main reason for that. And the other thing is, if only the stupid aggressive people breed, yeah, then humanity is really fucked. So the only way we have a lot of good people, a lot of geniuses, a lot of people who actually make mankind progress, if you think of the bell curve, is just to have more people. That means if we want to have more smart people, we also have to have more stupid people at the same time, right? And the other thing is that globally speaking, mankind became actually much more peaceful. War was really commonplace back then. I mean, in summer there was always war in Europe, basically every year, so it was really the exception if there was peace. And at the moment the world overall is very peaceful. It's just every war and every conflict is reported immediately all over the internet and all over the news. So people back then, they didn't even know if half around the globe some people were splitting skulls. I mean, nobody cared and nobody could find out. So I think people think that the world became more dangerous, aggressive and whatnot, but I think the opposite is the case. We're much more civilized these days and we value peace and stability much more than people did in former times. So I'm actually optimistic in this regard. So of course in the end it's your choice if you want to have kids or not. One of the biggest disadvantages of sexual reproduction is its cost, by the way. It is horribly inefficient in terms of ramping up your population, and it takes a big investment from the species. However, with all the beautiful results it can have and all the possible ways in which organisms on the planet can evolve and the direction we can give our species with proper mate selection and proper environmental adjustments, this is just an experiment that is too tempting for me not to try. And as it is in physics with a really expensive experiment, you don't just abort the experiment. When you start, you have to pull through. So thanks again for listening. Have a great day. Servus, Kameraden.